Yeah, we are looking at the second order differential equation, and in this case, all the questions here they are homogeneous. Two, yeah, the order is two. Okay, for each of them. So let's go straight to the solutions. Yeah, question one. This is what we have. Is equal to zero. This is homogeneous. Okay. In that case, now the auxiliary equation that will be 9r squared plus 9r minus 4 equal to 0. With the illustrations, the intro has been given on this video, so please you can watch those videos. We say that this differential, in this first differential will be r, in the second differential will be what, r squared. So 9r squared plus 9. Then there's no differential, that will be cos times. You just write the coefficient of that y. Okay, then in this case now, let's see if we can factorize this. This is minus 36 r squared. That will be 9 and 4 minus 3. Okay, you get this one to 2. Then if you multiply these two, you get back your minus 36. So we just have 9r squared plus 12r minus 3r minus 4 equal to 0. So these two numbers, these two factors will now replace the center one here. Okay, so instead of writing 9r, we just write this one. Okay, then you pair the equation together. Then you have here 4, and then 3r and 4. One is common. Then this will be equal to 3r plus 4 equal to bracket 3r minus 1 equal to 0. So this implies this is equal to 0. Then we have 3r equal to minus 4. So r is what? Minus 4 over 3. The second one, we have the 3r minus 1 equal to what? 0. R is equal to 1 over 3. So the general solution for that homogeneous equation will be equal to C1 r equal to minus 4 over 3x plus C2 e minus that's 1 over 3x. Okay, so that's that for that question. Question 2, we have second differential here plus y equal to 0. So in this case now, this will be r squared plus 1. Okay, the second differential, that will be r squared. This one is constant, just like the coefficient. There's no differentiation here. So this will be r squared equal to what? Minus 1. R is equal to what? Plus or minus I. The real part here is 0. So plus or minus alpha. So this is what we call the alpha. This is the attachment here. Is the beta, which is 1. Okay, the solution here will be 1. Y1 will be equal to alpha this, okay, cos beta x. Okay, so this alpha x, and then y2 is also e alpha x sine beta x. But your alpha is 0, so by the time you put it here, e will go. Okay, alpha in this case is 0, so we just have what? Cos what? Your beta here is attachment to your complex number, so just 1. So that's y1 is this, and then y2 is what? Is do the same thing also here. Then you have sine what? Sine x. So your general solution for the homogeneous part will be equal to y1 c1 y1 plus c2 y2, and that will be equal to your c1 plus y1 cos x, then plus c2 sine x. Okay, so that's on that. Then we go to question 3. Question 3 has some initial value. It has some conditions. When x is 0 here, y is 0. When the first differential is for first differential, x is 0, y is 1. So we look at that. One, we have second order is homogeneous. So the auxiliary equation 2r squared plus r minus 4 equal to 0. So calculative formula, a is 2, b is 1, and c is minus 4. And this will be equal to minus r is equal to minus b, your b is 1, plus or minus b squared minus 4ac A is 2, and your C is what? Minus 4 all over 2 times 2. And that will give us will be equal to minus 1 plus root 33 over 4. And then R2 will be equal to minus 1 minus root 33 over 4. So this is our answer. That's R1, that's R2. So this is the case of R1 is not equal to R2. So this will call the two distinct real roots. The solution will be y is equal to C1 equal to E 1.19 x plus C2 E minus 1.19 x. So that's what we have there. Okay, then the fourth one we have y second differential minus x plus 9y is equal to 0. So the auxiliary equation will be equal to r squared minus 6r plus 9 equal to 0. R1 will be equal to R2. R1 is equal to R2, which is equal to R. Okay, so in that case, this is a one equal root, or call it repeated roots, because that's where your auxiliary solutions, the root is the same. So in that case, now the solution will be equal to y1 equal to what? E2 power 3x, y2 will be equal to what? X e3x. Okay, so your general solution for that homogeneous will be equal to C1 equal to e3x plus C2 x e3x. But that's not the end here. We have some boundary conditions here. When x is 0, we'll do that. When x is 0, we have y is 0. So we have 0 equal to, plug in your x value here. So we have C1 plus this one here. This is 0. So we just have C1. So C1 is what? C1 is 0. Okay, for the first differential, just differentiate your homogeneous equation. Okay, if you differentiate that, you have 3C1 e3x. Then this will be product rule plus C2 into brackets. So that's that. Then let's put the condition there. X is 0, y is 1. So we have 1 here equal to, if you plug in, x is 0, this will be 1, that is C1 plus C2. This will be 1, that is C2 into bracket 1. This will be 0, x is 0. So we just have 1 there, 1 plus 0. So, and already we have C1 as 0. We have C1 as 0. If you plug in that, C1 is 0. Okay? So 0 times 3, that's 0. So C2 is what? C2 is equal to 1. So we've gotten that. So the general solution for that homogeneous will just be equal to C1 is what? 0. So this place will go. And then C2 is what? C2 is C2 is 1. So we just have x. This is 1, and then x. So that is solution for that. That's solution for that. Yeah, sorry for that. For the differential here is 2. Y is 2. I'm looking at this. Y is 2. So y is 2. Okay. You just have 2. So here is 2. Here is 2. So C3 is 2. C3 is 2. So this will be 2. Okay. You can see when x is 0 here for the differential of the solution, y is what? Y is 2. Okay. So just put the differential 2, differential of the solution 2, then do the other one. Okay. So that's that.